Solar modules are a very special product. They are supposed to live for 30 years and maybe even longer, and also with high performance, high yield. And that's the other particularity. If you have small changes in the performance, in the yield, you have it always has a big impact on the profitability. And that's why quality and reliability are really key. And industry experts are really, for them, it's really important to know about quality and reliability. And this is very entangled with the discussion on profitability. I think we have, for this quality session of the PV Magazine Roundtables 2022, we have picked 3 really interesting topics. One has to do with the lifetime assumptions. The other has to do with the accuracy of yield forecast. And the third one has to do how to then consider the outcomes of these other 2 topics, because it depends on the selection of your key performance indicators. Sometimes, in some examples, we come to that later, it depends on this selection which outcome you get for your best system. We start with module sizes. Module sizes have been developing have been becoming bigger and bigger since years. Seems to be only one trend: the bigger, the more efficient. And today we have a guest who says that, it doesn't even mean that bigger is not good, but he says you have to consider there could be an optimum module size. So maybe it doesn't make sense to go to the biggest modules which you can find on the market. I welcome Jason Yan. He is Senior Product Marketing Manager of Longi Solar. Hello, Jason. Hello. Please go ahead with your presentation, and then we meet back on the panel to discuss.
Okay, thanks for a kind introduction. So this is Jason Yan from Longi. I'm very honored to give a speech here. So today my topic is about there is an optimum model size. Basically, I think next slide, please. Yeah, thank you. So basically, on Longi, we think it's not always the bigger, the better. So through analysis across the entire industry chain in terms of the production feasibility, cost, and model reliability, system compatibility, and manual installation, and model transportation. So we think HAMR 5 based on M10 182 millimeters wafer is determined as the optimal model size to realize the standardization of the manufacturing and application system, and it can also realize the actual reduction of the model manufacturing cost and the system cost. So basically, you can see Longi's M10 PERC has achieved about 23.8% cell efficiency right now, and we think at the end of this year, so the cell efficiency will close to 24% for the PERC, for the M10 PERC cells. So basically, the HAMR 5 model can reach to 550 watts with an efficiency about 21.3%. So the model length is about 22.78 millimeters, and the model width is about 11.34 millimeters. So we think future innovation should be focused back on the improvement of cell efficiency and the model efficiency and the engineer, but not further increase the model size. Next slide, please. Basically, for HAMR 5, based on M10 model, we offer 2 kinds of model in the following picture. So firstly is I think the small one. The length is about 17.22 millimeters, and the width is 11.34, which is suitable for the DG market. And for the utility scale market, we can offer 22.78 millimeters length and 11.34 millimeters width model. So the basic idea for the unified size for M10 model is that I think we think it's beneficial for the whole industry that means if we have the standard size model, the industrial supply is reliable, and also it's very beneficial for the downstream power plants construction, because as you may know, when you have a standardized size model, the EPC and installers, it will make their life much easier because they do not need to keep changing, keep design the model or power plants design. Basically, that's a point for the standardized model. And next slide, please. Okay, so because the M10 model, I mean the HAMR 5, is based on the thorough analysis across the entire industry, and we are focused on the customer value. So the market share of M10 model actually exceeds the expectation, so which will quickly exceed half our market share actually in last year. So for the M10 model, the global shipment is about 48.5 gigawatts. And we think this year, according to the PV InfoLink forecast, the M10 model's market share will over 50% this year. That's a good sign, indicating that M10 model is well recognized by our end customers. And also, so last year, I think this year, third party also adjusted some of the market share of the M10 model, I think, to over 50%. That's simply because I think a lot of the G12 production can switch to the production line to the M10 model. Okay, here, I think next two slides. Next slide, please. So in next two slides, I will show the methodology behind that, why we think that it's not always the bigger the better. There is optimal model size for the, which is the M10 model. So in terms of the model reliability, we can see a lot of experience tests show that when the model width increased from the 1.13 meters to 1.3 meters, the maximum deformation increased about 40%, which will result in the higher micro crack of the cells. You can see in a row. So for the 72 cell M10 model, it's the micro crack of the cell is about, I think, 3 and the number. For the 66 cells 210 model, the micro crack, I think the number goes up about 20, over 20 cells has micro crack. That's a big issue. So in one hand, the power degradation caused by micro crack will increase, and in another hand, so the risk of glass breakage will increase with a significant increase of the model deformation. And next slide, please. Another issue is about the engineered performance. Basically, as you may know, so in the previously half-cut model has the engineered advantage compared with the full cell model. So the simple mechanism is because for the half-cut model, the current is half. So that means the internal loss for the model is less than the full cell model. So we did a pilot project for compared with the M10 model. Actually, the operating current is about 30.7 amps, and for the large current model, ultra large size model, the current is about 18 amps. So that means the current is about 30% higher than the M10 model. We can see in this figure, interesting funny that actually when the irradiance is higher, the higher energy yield for the M10 model. So that's similar results with the half-cut cell and the full cell models energy yield. So in this figure, you can see the yellow line is the energy yield, and the dark line, I think is dark line is 210 model, and the red line is M10 model. So basically, when the irradiance is about 500 watts per square meters, the yield gain is positive for the M10 model. So we think the results show that the model design direction of PV model should be focused on improve the efficiency and control the internal loss instead of keeping increasing the currents. I think that's all. That's all my point. Thanks very much.
Thank you very much, Jason. Very clear and transparent message that you think you should work on these efficiency losses instead of going to bigger modules. We will immediately discuss these topics, but we have invited 3 more guests to discuss this. I welcome our other 3 guests from the very well-known EPC Belectric. Hello, Djaber Berrian. He is PV Innovation and Design Engineer at Belectric. Djaber, are you coming? So I think we still have to wait. There we are. Okay. There I see Djaber is not there so far, but I first welcome Patricio Sanchez. He is project manager from the very well-known PI Berlin. Hello, Patricio.
Hello, good afternoon, everyone.
And Christoph Mayr. He is business manager photovoltaic systems from the Austrian Institute of Technology. Hello, Christoph.
Hello, everybody.
And for those who may have tuned in later, the 4th guest on our panel is Jason Yan, Senior Product Marketing Manager of Longi, who has just given us his presentation. Jason just presented why Longi does not believe in the very big modules, but only in big modules. More in technical terms, he says modules from M10 wafers, M10 wafers have an advantage compared to modules from M12 wafers, because the M12 modules are about, I think, 30% broader, if I'm correct. One of Jason's key argument is that the microcracks, that under pressure, this larger module would evolve more microcracks. Christopher, you also run a test lab at AIT. Do you have done such comparisons, M10 to M12 modules? Okay, can you comment on this?
So thank you for the question. Actually, we did not do comparative testing, but in terms of mechanical stress test of large-scale modules, it depends a bit on the module design. How strong the impact on the cell cracks is. So we have glass modules with a more stiff behavior, and we have also glass laminate modules with a reinforcement on the backside with an additional bar. And so it cannot be said in general that there is a stronger impact on this large size modules. So it depends a bit on the module design here.
So you would call for a holistic approach, if I understand that correct. So you have to see all together at the end. And if we would see all together, let's say same construction method and all this, but then different module size, then it's a bit, let's say, self-understanding.
Yeah, in terms of higher currents, that's self-speaking. Higher currents mean more losses usually. So that was also the way to go for half-cut cells and this new approach with half-cut modules. And so higher current means more losses in general, yes.
At this point, I have a question to Jason, because you make this point in this comparison of this current, when you say that with these bigger modules you have a bit less efficiency because you have higher currents and more losses. You compare, as far as I understand, M10 half-cut cell module to a M12 full-size cell module. Is that correct?
No, I compared the M10 half-cut cell and also the G12 half-cut cell. I think all the cell is half-cut because, mainstream cell is half-cut.
So that means you have this higher current in this bigger module also, if you have a high half-cut cell module for this bigger one.
Yeah, okay. Exactly, because the wafer is bigger, 30% higher, bigger, the area.
Okay, coming to Patricio, I would like to direct the same question which I asked Christopher also to you, because you also run a test lab, and I'm sure you also do pressure and load tests. Have you done comparisons?
Not their comparisons per se like that. I would say they're same approach, project specific sometimes, but in general, glass frame would be a safer way in terms of micro cracking. At least something we can try to reduce in the long term, not only from installation but also transportation, because of all the activities that we don't see, and we are able to check after commissioning, for instance.
Okay, but that means if you're asked by companies to check after commissioning, for example, and do you see then when you go to construction sites, for example, with M12 based modules and M10-12 based modules, do you see any difference statistically, or is that, I mean, it's a bit like Christopher says, that there's so much other parameters that you cannot really separate?
Yeah, there's so many others that one would need to really look for root cause analysis for a specific type of module and then track it back to see whether that was a construction issue or a design issue, or it was just during transportation something went wrong. At the end of the day, we tested regardless of the module type on site, and we try to highlight whether at the point of interconnection and commissioning that everything is fine. So that's really the point where we have to make sure that the module is properly also installed, because the installation also plays a role here according to the size of the module.
I mean, generally, I'm a bit wondering, because I mean, we have this discussion always when we're talking about quality. You do the lab test and you measure some parameter. In this case, you do an artificial load, then you measure the microcracks. How far is that related to what do you see in the field at the end, Christopher?
Yeah, it's a bit different because you have a design load and a test load, and finally you have a implemented solution on the field, and this depends on the selected mounting structure finally. And for example, the manufacturer is doing, let's say, the design load testing, and this does not necessarily reflect the same situation as then in the final mounting location.
Okay, now I have to ask our back office whether Djaber would come now, because from Belectric, because that depends a bit which topics we do first. Hello. Here he is coming. Great that you made it to our panel. Djaber Berrian, PV Innovation and Design Engineer at Belectric, well-known EPC. Hello, Djaber.
Hi, everyone. Good afternoon. Sorry for...
Hello, that you're coming just at the right point, because we have heard in the last minutes about how one has to interpret this test results of Longi, that you can see that, of course, if you do everything the same with a bigger module and an even bigger module, that you have probably more bending with the even bigger module, but it's not so sure how that depends on the mounting structure and what the effect in the field is. But I would like to know from you, because you as EPC have to pick modules, is there a preferred module size which you pick?
So, well, when it comes to this large format PV module, what we did actually, we looked to two things actually. We looked how actually this large format PV module M10 and M12 compared to the M6. We definitely found actually a big advantage. Therefore, we are moving to the large format. And the second question, whether if we have a choice in terms of M10, M12, we actually find it really difficult because there is very tiny difference. Therefore, we did not really have, we do not so far have really a conclusion on whether we go with M10 or M12. We usually look at both product on project specifics. So, yeah.
Yeah, I mean,
there is no one defined product yet.
Yeah, I think you are running also economic optimization programs because you have a sophisticated software for this. And this leads me to our second topic of this panel, because you say when you do this optimization where you can compare, for example, compare this M10-based modules or this M12-based modules, you have to select also a key performance indicator. It can be, for example, the LCOE, the levelized cost of electricity. It can be the ROI, the return of invest. It can be the net present value. And you say that what the optimized system which comes out of this optimization depends on the selection of this key performance indicator. And this is a complicated topic. And to make it more clear, I would like to give you an example. Just imagine you have a piece of land. You now can install on this piece of land either mono PERC modules, or you can install on this piece of land heterojunction modules. Same space, same area. Probably the latter one, the heterojunction, is a bit more expensive, but it gives you a bit more yield. How does it change the outcome of this optimization, what you pick, whether you take, for example, the LCOE or the net present value as indicator?
Well, talking about this example you gave, or the one project which recently I worked on, where we would like actually to push TOPCon in comparison to P-type. For that project, what we see is that if we look on LCOE based, we see one PV module technology winning. If we look to the net present value, we see a different PV module winning. So depends on the KPI. Actually, we look at it. You have different PV modules, technologies, and also system designs completely, like substructure even.
But why is that the case? Can you give us an idea why there's a different
So the
outcome?
so the reason behind this is mainly because when you work on solar projects and use the LCOE, you are looking for, let's say, the lowest capex and opex, and also the lowest return investment. But if you look to the net present value KPI on one project, actually you would like to maximize the returns. And also, when usually we do optimization based on net present value, the volume plays a role here. Means you would actually put as much as possible volume, let's say megawatt peak in the plot, to get as maximum as possible returns. And this is actually what net present value captures, but not the LCOE.
Do I understand right that this, for example, means that I can, if I do this optimization with the net present value, I would end up to invest more, but maybe at the end to a slightly lower return of invest. But I'm happy as investor nevertheless, because I know where to give my money to.
Exactly. This is what we see actually from the investor point of view. As soon as they have land, they would like to put the biggest volume as possible, because land is expensive, for instance, in Germany or Netherlands, rather than actually looking for the lowest return systems like using the LCOE as a KPI.
Yeah.
So yeah, absolutely, it's right.
Patricia, I suppose you also do consulting for investors for these topics. Do you make similar experience?
We have a similar experience, but I would like to highlight that it really depends on which side you're consulting, because it's not a common solution for investors or from EPCs. You need a high volume, and you try to really pack with modules the area available. However, sometimes you deviate from the module efficiency or from the module tilt angle just to reach more install capacity. And you get the number, and you can have your net present value. The problem is, in the long term, when we look at projects or we work with asset management or with operation and maintenance companies, flattening the angle in the long term brings other expenses and perhaps even other issues on the O&M. So one really need to think what is the point of the design and what to expect in the long term. Now that we're looking for projects into 30 and recently some 40 years old lifespan, I think we could see really differences in the design based on whether it's long-term or short-term investment.
I have the impression that there's a, let's say that that net present value as key performance indicator is the preference, but we should also explain it to our audience. Djaber, can you explain this complicated magnitude to our audience?
Actually, it's not really complicated. It's just the the difference between your sales of electricity and then your investment costs, let's say the capex, opex, and other financial costs. And this is what to give you your net present value. So the difference to LCOE, it's this an absolute number, so it's usually in euros and dollars, but LCOE it's a relative number, which is also independent from the volume.
But you do it also at costs of today, so you have to account also for some
of course,
depreciation.
This is very important. Exactly, looking to the holistic case assumptions.
Yeah, but I think Christopher, I think you have also an argument for LCOE.
Yeah, LCOE, it's an interesting value to cross-check when it comes to PPAs, for example. Yeah? If you negotiate your PPA, you may want to know what is your levelized cost of electricity of your plant and what is the minimum price to sell your energy. So that's a very important indicator.
I would come to one point which also goes in this optimization, which is very important, and that is the yield forecast, because either what you calculate, be it the LCOE or be it the net present value or the ROI, you need a good yield forecast. Djaber, when you are really evaluating your projects, which uncertainty do you normally assume, and what is the most uncertain input?
Well, talking about system designs, for instance, when choosing between different configurations, usually it's two main sources of uncertainty. It's the yield and then the megawatt peak in the plot. And the yield in the end comes from the pan file quality, which is the input to PV system. This is actually where we see usually when you look at system design between different PV module technology, this is actually has to be carefully checked. Otherwise, can have a bigger impact to.
So that means you rely on really accurate pan files at the end. That is high quality.
Exactly, accurate or high quality. Exactly.
Maybe we can discuss later what you mean by high quality for the pan files, but we have prepared a video insert because we have published a detailed article on pan files, what you should know, in PV Magazine April edition. And the author and PV Magazine editor, Marion Viljoen, has prepared this short video insert because unfortunately he cannot attend today to our roundtables. Please play our video insert.
What is a pan file?
Pan files are essentially extended data sheets that hold more detailed information about the electrical properties of modules. And yield forecasters need this information to make accurate forecasts. The special thing about pan files is that the information that they hold that cannot be actually measured, but it needs to be deduced from making a low light power measurement.
How are pan files created?
They are essentially three ways to make pan files. The first is that PVSys or a similar software provider looks at the datasheet of a module and applies its own general basic assumptions, default values, and makes them to a pan file. The second way is that a module manufacturer sends in its module to a third-party laboratory to make a matrix low-light measurement. And going from these values, PVSys can then alter its basic assumptions to make a slightly more accurate pan file. And the third option, module manufacturers would, after they have tasked the external laboratory to do the matrix low light measurements, they would ask the same laboratory to generate a pan file from those values. And the third one is also the most common one at the moment.
What can happen if a pan file comes from a third-party lab rather than PVSys?
When a module manufacturer asks its own third-party laboratory to do the pan file, then this pan file will not be automatically put on PVSys, but you will have to ask for it when you're an EPC and you want to buy these modules, then you'll receive the pan file.
How can module manufacturers choose their pan files?
The easiest way to choose a pan file is by altering the IAM factor. That's the incidence angle modifier, and it tells you how much light is penetrating the glass. at a certain angle. In the past, it was said that glasses have this penetration rate of 95%, but more and more module manufacturers are putting 99.
Patricio, now we've just heard some, let's say, basics about pan files. What do you recommend that one gets a high quality pan file?
Yeah, first of all, you have to get your pan files validated by an independent third-party laboratory, because we kind of put together module QA during manufacturing audits, and in this way we monitor production, and at the same time with this we reduce the chances that manufacturers, let's say, cherry pick the samples that will be sent to the labs to do testing. So in this way, it's a very transparent, random process of module selection to validate the complete batch and not specific modules. With these modules, you test them for specific parameters, as you saw in the video, low light behavior and incidence angle modifier, and so on. And with these lab results, we assess the behavior of the module for specific site conditions. Yeah. For instance, where the PV plant is going to be installed.
But that, if I understand right, that you are doing for really big projects where you can do really this extensive analysis. But if you're, for example, using the pan files which you get from module manufacturers, what do you recommend then to be sure that it's a good one, accurate one?
You can request the testing, the third-party testing and the certificates. And with that, you can validate, okay, how this testing was performed, the angle of incidence for the light, at which angles was measured, how many modules were tested for bifacial measurements, and so on. Yeah. So if you don't have the budget to do it, at least you can validate or double-check the testing.
Yeah. And have you made also this experience, what we have just heard in this video, that there are different assumptions for the glass transparency which are used when we do pan files? And I mean, when I hear this, I'm wondering, does the glass getting, I mean, it's possible glass is getting better, anti-reflection coating maybe. Is it getting better, that so it's justified to use better transparency factors, parameters, or is that really choosing pan files? What do you think?
For transparency or for AOE measurements, for incidence angles?
Yeah, I mean this angle dependent. Yeah, this is angle dependent.
No, actually, we have seen a lack of awareness on the way this testing is performed, and we see sometimes very unrealistic curves. There's some physical laws that will make highly unlikely that these curves can be exceeded. So when we see these reports, sometimes we think that we don't want to say that it was wrongly performed. It's just the uncertainty is so high that there's no way to have a reliable measurement. And when you transfer this to actual simulations and let's say low light behavior, you can have differences in the yield about 4 to 5%. And this number for low margin projects, it could be a project killer. So it's
can you see this at the end of these reports? I mean, if I'm now asking for this report, can I see what they have done concerning this angular dependent parameter?
Correct. They measure different angles, the module, and then per measurement you have different uncertainty values that you can
Jason, you are the module manufacturer here on the panel. How does Longi handle pan files? Do you have third parties, and how do you handle this? I don't know whether it's now quite a specific question, how to handle this angular depending parameter?
Yeah, basically, at Longi, when we provide a pan file to our customers, usually always we will test the pan file parameters by a third party, and we will offer our customer the third party report. And another point is that also we will cooperate with our customer, or we will build a lot of pilot projects over the world to verify the energy yield and compare with the PV system simulation. So the idea is to make sure that the simulation of pan file the engineer, is consistent with the real field test, so that it can deliver high value to our customer.
So there's a sort of a double check of this pan files.
Yes, exactly.
Djaber, at Belectric, you said that the quality of pan files is really an issue for us. Do you see a lot of not so qualitative pan files on the market?
I would say depends. There actually, but usually what we do is to request the pan file along with test reports, and these test reports should come from institutes which we name. So based on this, we can achieve to a quality pan file, a good quality pan file.
But you now say quality of the pan file. How do you specify quality of the pan file? Does that mean, for example, how you measure this angular dependent parameter, or does it mean at least it's third-party certified, or what is the quality indicator for you?
Yeah, so it's a combination between third-party test report and also some sanity checks, like what we do for the AM profile, for instance. We look if the AM profile provided in the pan file is, for instance, aligned with the Fresnel module, let's say the physical model from the AM profile. So if the AM profile which measured is within this physical model, then we accept it. But if it's beyond that, then we just use the physical model. So also we look to the low light behavior and do this based on technology base. So for instance, we say for the N-type PV modules, we expect to have a better low light behavior than the P-type, and then we do this accordingly. So there is some sanity checks. We do it on top of the test report, which we get from third-party institutes.
I think, Christopher, when we prepared this session, we also discussed about this question, why there is no standard. And you have an answer to this, because it's crying basically for a standard. This, particularly when you think on the smaller EPCs and projects which have not the measures to ask PI Berlin to do a sophisticated sample measurement and testing.
I may do not have an answer why there is no standard. I can just confirm that there is no standard to transfer the measured data into a consistent pan file. But the basis for doing the measurements, they are described very well in standards. So you have different IEC standards for the temperature correction and the irradiance correction and the energy rating. So you can do the measurements according to a specified procedure, but then transferring these measurements into the model and handling then the model in the simulation tools, then this is the tricky part. And as you mentioned earlier, there are several ways to do that. And but what we have seen also is that it can go, the pan file quality can go in two directions. One is to make it a bit better and then to sharpen the results in a better way, but also some lack of data in the pan files, which leads to not so good results then for the simulation, and this is not good for the manufacturer at the end, that the yield calculated is less than it could be finally for the final product. So, and this applies in particular, we have seen it in particular for bifacial modules, where a manufacturer did not indicate the bifi factor, for example, and did not take into consideration this in the simulation. And so the results were worse than it could be.
And how does this error which comes via pan files in the yield forecast compare to the error which comes in by the uncertainty of the irradiation forecast, or irradiation, which I assume?
So when the question goes to me, then I may answer this as well. The yield forecast and the yield estimation is also one input parameter is the weather and the meteor data. And as we have seen, these are historic data, and you try to do a forecast and a calculation for the future. And of course, you have some uncertainties here. And it depends what database you're taking and you're inserting for your calculations. You can have deviations up to 5% at minimum.
Is there agreement, and that I really would like to know from each of you, Is there, let's say, a common assessment how big the uncertainty of yield forecasts is? Is it 5%? Is it 8%? What is a good number?
A good forecast, due to all the uncertainties, a uncertainty of 4% would be, with pure satellite data, I think would be reasonable. And then this can be maybe fine-tuned with on-site data, where you can reduce this uncertainty through validation of on-site data plus satellite data. But really depends also on which region of the world you are, how good the pan file and the type of sanity checks you perform during the energy yield evaluation. With probably all the checks, I would say 4%.
Do the other agree? Djaber in particular, now from the system side, Djaber and Christopher? I don't know
yeah,
whether
I can
Jason
add
has an
here.
opinion on this.
Yeah, I can add here. So actually, yeah, if you pick up PV system, you have a lot of inputs, and every input has a sensitivity. And if we look to what we can reduce this, actually, I see this to up to 2%, because they did in the past some validation of PV tool. So in the end, you still have the model actually errors, right? So I would say if you have everything perfect, it's what we did in the past with on-site measurement and what our colleagues here mentioning. So in the end, you will still have about plus minus 2% due to the model itself.
Okay, Christopher.
So yeah.
Yes, our partners reported from the operation, designing and operation of plants, that the energy yield output in the final implementation was even higher than in the energy yield calculations beforehand. So
yeah, okay, I mean, it can go in both directions, the error.
Yes, right. That is what I want to say here. But you have some uncertainties, but they can be in both ways, plus minus.
Jason, I mean, you are doing this double checking, so maybe you also have an opinion on this.
Yes, so I mean, at Longi, so we have built a lot of pilot projects, and also, as I mentioned previously, when we launched a new product, we also we will co-opt with our customer to build the pilot projects to verify the energy yield for the energy yield. And so I think until now we received a lot of feedback from our customer regarding the energy yield for our models. So I think all of them tell us the story that our energy yield is actually higher than expected than the PV system simulation. So that's a point. So because because the methodology, when we provided the pan file, so firstly we verified it by the third party, and secondly we verified it by the pilot project.
We have to move on, but I would like to, because that is interesting. I mean, Christopher said sometimes the yield is higher than forecasted. Jason said very often the yield is higher than forecasted, and that is a big difference, I think. Just one sentence, Christopher and Djaber, would you say yield is very often higher than expected, so one can really be positive about this? Just one sentence.
If I start, I would see, I mean, like, yeah, long term and looking depends on the data and so on. I see actually it's hard actually to get measured yields higher than expected.
Okay.
Especially if we think, I mean, like if you think about soiling, degradation, and so on.
I would say it's rather higher, and then that would be a rather conservative pan file, which is probably the least worst of the scenarios.
Okay, Christopher, I would like to conclude this panel with now a bit more to take the angle of customer group, which you have a lot because you're coming from Austria. You have a lot of smaller customers, also smaller EPCs, and you do this consulting also for smaller projects where you cannot do this big evaluation. What do you recommend them to, in short, what do you recommend them to select modules?
Yes, in addition to the point what I learned here now in this group as well, to do a desktop check of the pan file quality, So in addition to that, we recommend to do a pure document-based check of the modules, which starts with the data sheet. It goes to the availability of the certificates. Do they exist and are they plausible, or are they just fake certificates? How is it about the extended warranty declarations and the conditions? And last but not least, also about the mounting instructions. What does they say, and how all the product is appropriate for the individual project? So in general, how does it look like with the full documentation of the product? And if all of that is not enough, we recommend sample testing in the lab. And this number of sampling depends on the project size, and it goes to one module up to several.
And I think, because we have
packaging
really to
units
be
of
short now,
modules.
I think you say it's possible or feasible to do that from installations from 100 kilowatt peak on.
Yes, it's possible from every size, but lab testing starts with a significant project
I mean,
size.
you need the
starting from
volume. I think
100
you
to
cannot
200.
pay it.
Yes,
Okay,
right.
thank you very much for this very interesting discussion. And goodbye to our panelists, Djaber Berrian from Belectric, Patricio Sanchez from PI Berlin, Christoph Mayr from AIT, and Jason Jan, Senior Product Marketing Manager from Longi Solar. That was our quality session of PV Magazine Roundtables Europe. I hope you can take some takeaways at home. I have 3 ask for pan-file reports. Choose the adequate key performance indicator when you optimize systems. And size of the modules, I would say ask your manufacturers for commenting of what we just heard. See you again in 15 minutes for the PPA sessions. These unsubsidized business models, which are related to PPAs, are the first to feel the consequences of cannibalizations. We will discuss this risk and how this should be shared with the market players involved in the PPA, power purchase agreement business model. See you soon.